I think they have applications in a couple of areas. Certainly, if you're running a solar production facility, they provide a means by which you can anticipate what's going to happen in the very short term. So, for instance, if you have a megawatt of power, or more than that, or 100 megawatt or a gigawatt, and a large cloud comes over, you're dropping a huge amount of power from the grid. And if you can give the grid operator a heads up that, look, in 35 seconds we're going dark, this will allow him to bring in other sources of electricity and manage his job. As solar farms get bigger, this is a real problem. Okay, you know, cloud right now is not a big deal, but if you're running a gigawatt-sized solar production facility and a cloud goes over, you're pulling a huge amount of power off the grid in a very short time. And by the way, that cloud may go by, and then 30 seconds later, it goes right back up again. So that's a tough problem for a grid operator to manage. The other thing that has been interesting is we've used these cameras over distance to estimate cloud height and velocity. So there are long-range sensing possibilities here. And you know, since this particular prototype was constructed, we've miniaturized it and made it much, much less expensive. And over time, I think there's a nice possibility of distributing these things. So it will give you the ability to look at clouds, heights, velocities, and things that may be of interest to aviation and other people.